This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Hi, everyone, and welcome to the latest live Slooh show. This is the third part in three of Slooh Journey, this little spacecraft that could has taken. We've seen it years and years back, starting this incredibly long and beautiful journey across the solar system. We've seen it as it goes further and further along, and it actually went by Jupiter as well, getting a gravitational assist from that planet ever further and get a flyby of Pluto that we have just very recently experienced. But before it got to Pluto, there was a moment of silence after Jupiter, a time that it went into hibernation. 2007 was Jupiter, and now it's 2015. It went across the orbits of the planets, but did not encounter Saturn, Uranus, and Neptune. It continued until all of a sudden it came and approached the dwarf planet Pluto. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios in Slooh HQ in Washington Depot, Connecticut. And today we are going to be looking at the latest imagery that has come out of this incredibly close flyby. 7,800 miles away was where New Horizons got in terms of Pluto. And right now we are looking at a beautiful live image from the Canary Islands of Pluto as we look at it back from Earth, taking a step back before we take a huge step forward, Pluto being in the center of the frame. And so we are looking at it from the Canary Island scopes, which are up about 8,000 feet above sea level. 95% of the skies are clear. We actually have an all-sky view of the Canary Islands right now, which shows you that this might not be one of the clearest nights. But even though there are a bunch of clouds, we are opening special for this show to get some live images of Pluto as a pinprick of light amongst a blanket of stars to give you incredible contrast for what it means to travel across the solar system and look up close and personal at this incredible dwarf planet. And so we are actually going to be taking some questions throughout our show using the hashtag Slooh New Horizons. And so you can ask us questions about what you might be curious about because there's a lot to discuss. And here to discuss it with me is Slooh astronomer Bob Berman, who's going to take us through this whole journey together. And as we just see our crosshairs on Pluto, that's where we're aiming tonight. Thanks so much for joining me, Bob.
We've waited years and years, probably our whole lives, for this final visit to a planet. I mean, okay, dwarf planet, but still, this is it. We've just got the images, the first images in. Oh, major thing happening.
Absolutely. And so what we were just seeing was an animation actually that so Slooh members have been looking at Pluto in celebration of this historic flyby throughout the week. And so taking images day by day to actually show movement around across the background stars, which we're actually going to be talking about a little bit later in the show of how Pluto was actually discovered. But for now, we're actually going to take a look at those first images that have just come out today of the flyby. We've been leading up to them now, but here we have the first real image we have of one of Pluto's moons. We have of Hydra, which is it's we see a little bit of pixels here, but we also see unique shapes. It's not exactly the circle we would think of when we look at a moon, and this is actually a moon that is very very small. It's about 28 by 19 miles in terms of length and width, and so what does that sort of mean? What can we really compare that to, Bob?
Well, we could compare it to what it is, a piece of junk. The outer solar system has major moons like Saturn's Titan and Neptune's Triton and the four giants around Jupiter. And in fact, we can add to that Charon that I know we're going to look at momentarily. And it also has little tiny things, 20 miles across, 25 pieces of flotsam and jetsam, most of which were captured, other pieces of ice that were captured. And so, yeah, a little trivial piece of ice there. Small, much it would fit in, the suburbs of a major city.
Right. Yeah, I believe we have a comparison of what this moon would look like when it's placed on the city of Denver, and so there is Hydra right there, or around around the major city center. So it's something our Earth could easily eat for breakfast if it wanted to with its cereal. Let's put it
Yeah,
that
that's
way.
right. You could drive across it in a car, in an hour or so, and no easy paths or toll booths or anything. We'll never send a separate mission to it, but you have to take a look, while you're passing. And there's the major things that the New Horizons mission is looking at. But while you're there, you want some looks. I mean, not much resolution at this scale, but it's still more than we knew before.
It just blows me away that we can see something this small and this distant from us, albeit in this sort of pixely state. But it shows how deeply we can search the solar system for even the most really insignificant in size objects. And so we're giving you a quick highlight of the latest and greatest imagery right now. We're actually going to go into a bit more detail a little later, so we'll come back to this. But now let's get a little bit of a close-up look at Karen as it's seen from the close approach, and just look
Wow.
at the detail of this image. Like, can you give us just a little bit of a surface overview? Like, what are we seeing here, Bob? What are some cool things that are popping out to you?
Well, unique. Well, we knew nothing about Karen before. First, you've got near the pole a dark region. We're used to most poles having lighter poles, but this is a some kind of volatile, thin surface covering. But the main thing is that cliff area you see below center, extending from right to left across almost the entire body, like an escarpment, a cliff that runs. Uh, we're only talking about some 700 and something miles across. Also very curious is that feature in the upper right at the 2 o'clock position. It looks like a circular basin seen sideways. We're going to have a better look at that soon, but very exciting. And craters. The importance of that will be clearer later on in this broadcast. But look on the lower right, and you see there's a whole bunch of impact craters.
Yeah, there's a lot of features, and we're gonna go over this more. I can't emphasize this enough very soon. But now, without further ado, giving you the first look at some of the highest resolution, well, the highest resolution we've ever seen of the surface of Pluto. So this is what we saw a few days back, and we're going to actually zoom in on a portion just to the bottom left of that heart. You see that square coming up. So this is only the first part of a mosaic of images that is coming in, and there we have it.
And there we
This
have it, the first close-ups of Pluto. Already we see surprises. First, the mountains are 11,000 feet high, about the height of the Rockies. Now, those are significant mountains for an object so small. Pluto's only 1,473 miles across. Hey, that's only two-thirds the size of our moon, so it's a small body. And to see mountains of this size, that's significant for such a small object. But more exciting, perhaps, or intriguing is what we don't see. Where are the craters? There aren't any so far. I mean, none. So when you don't have craters, there's two explanations. Either this is an area that just doesn't get hit. After all, it's far away from the asteroid belt, which is mostly between Mars and Jupiter. This is way out. So maybe there aren't a lot of asteroid fragments and comets to hit these objects. But no, that can't be the case because we saw that Charon has a bunch of craters. And anyway, would have expected some impacts anyway. So that leaves us with the only other explanation, which is that Pluto gets remade, that it's a youthful surface, and that some process is going on. Nobody has a clue what that is, that creates a youthful, brand new surface. We see that in Europa around Jupiter. That's caused by the fact that it's liquid water turning to ice. We see that on Io, also around Jupiter, because that has active volcanoes, 7 or 8 at a time going. We see it on Venus. Nobody even knows why on Venus, but we don't see craters. We see a brand new surface being recreated, either suddenly, maybe every 100 million years, or maybe slowly, but it's new. Now we're seeing this again on Pluto. So back to the drawing boards and figuring out why a distant object could have this kind of youthful appearance. What's the process that's creating a new surface so frequently?
it's really true. There's so much going on here, and this is just we're giving you a quick play-by-play now. And what we're actually going to do is we're very quickly going to bring in an interview that we had earlier in the week with the Dr. John Spencer, who's a big part of the New Horizons science team. And he was talking with Slooh astronomer Will Gator a little bit about his hopes and expectations for this mission. And what we're going to do is we're going to listen to that interview, see what he has to say, and then I'll do a little bit of a compare and contrast. Like what wishes came true, what's still up in the air, and what can we discern now that we are past the flyby and the science is coming in. But before that, just a quick reminder, you are welcome to ask us questions with the hashtag Slooh New Horizons. When we're talking a little bit about what the implications are of the flyby after the interview, that's going to be a great time where we can bring in some of your questions and curiosities to address. And of course, cannot forget to mention that this is just one show of many for Slooh. We're on the air all the time. Look forward to our coming up shows as well. We're going to be on this Sunday talking about the $5 trillion asteroid. What does that mean? Well, it could mean a lot of money. And what does asteroid mining play into that whole deal? And so we have that coming up just this Sunday, and we also have the Delta Aquarids, a meteor shower show. We've been having a bit of a dearth of meteor showers, and so now meteor shower season is going to be starting to pick up again. And so look forward to that coming this Tuesday, or next a couple Tuesdays later, July 28th. And so that's coming up very soon as well. But yeah, for now, we're going to be going into this very interesting interview that Will Gator had with John Spencer. And so listen to that and stay tuned for some intriguing discussions that we can have about that just after. So look forward to it.
Well, I'm delighted to be joined now by Dr. John Spencer, who's one of the science team members on the New Horizon team. Dr. Spencer, thank you for talking to us this evening. I know you're incredibly busy at the moment. What's the mood like on the New Horizons team as we're just a few days away from the flyby?
Oh, we're we're having a lot of fun here. It's very exhilarating being this close to the encounter, just getting new pictures coming in every day, and we like speculate like crazy on what comes on each day, and we know by tomorrow's images will probably prove our speculations wrong, but that's part of the fun of it. And it's really a unique time. You don't get to explore a new world, especially one the size of Pluto, very often at all. It's been 25 years since we approached an unknown world as big as this one, and it'll be decades before we get another chance to do so. So this is really an amazing and exciting time.
Are there any last minute preparations in terms of what you need the spacecraft to do, or is it sort of going to do it all itself from here on out?
Well, the spacecraft has its instructions now. They've been uploaded to the spacecraft last week after we had that little glitch over the last weekend. And so it is simply executing the encounter load, as we call it now, and will be executing that until a few days after encounter. There's a few updates that we send up from the ground. We will give it the best possible knowledge on where it is relative to Pluto based on images that come down. We're getting a series of images right now where we see Pluto against the star background and its moons against the star background. And we use those to do a last minute update as to exactly where Pluto is going to be at closest approach, so we can point the cameras in the right direction. But other than that, it's simply executing the plans that we've spent years developing and that were practiced on the spacecraft a couple of years ago. So it's been through all these maneuvers before, and we have confidence that it will execute them all successfully. So yeah, mostly now it's very busy on the ground, but it's mostly busy, at least for the scientists, in trying to make sense of what we're seeing and getting ready to tell everyone about it.
You mentioned the images, and I know we here at Slooh and thousands of people online on social media have just been captivated by these daily pictures of Pluto that sort of is starting to loom ever bigger in the field of view. What's your impression as a professional scientist of what we're seeing in these early pictures?
I think I can safely say we're still baffled. The images are amazing. They look like no other world we've seen before, really. And they're covered in features that we don't understand. There are things that might be craters. They look vaguely circular, but we really can't tell yet. There are these very dark regions near the equator, which we suspect are some kind of hydrocarbon deposits from compounds that have been cooked up from the methane in the atmosphere, though that's still speculation. And then there are very sharp edges to those regions compared to the bright regions next to them, and we don't know what any of that means yet. we hope that things will become clearer as we get to the close approach images. We will get pictures that are 100 times better than what we're getting right now, and we'll get some of those next week. So we won't have to speculate too much longer.
In terms of the features that we see in these images and what you expect in the flyby, what sort of geological formations might we see in the coming days?
Well, that's really the $700 million question. We really don't know if a world the size of Pluto that is not in orbit around a larger body that might produce tidal heating, like some of the moons of the giant planets, whether it is capable of generating enough heat in its interior to support active geology, ice volcanoes, or faults, or things like that. And so that's a really key question about worlds this size, and it's one that I think Pluto will help us answer over the next few days. So we might see a surface that looks something like Neptune's moon Triton, which has a very exotic surface that we don't begin to understand, of smooth plains and faults and blobby regions and things we call cantaloupe terrain, because they look more like the surface of a cantaloupe than anything we've seen anywhere else. But that's a very young surface with very few craters. And we don't know whether Triton has produced all this activity because of its intrinsic ability to produce heat in its interior from radioactivity, which Pluto can do as well, or Neptune in some way. And so if Pluto looks like Triton, then we know that just radioactivity is sufficient to power these exotic kind of formations. And if Pluto looks like a much older, heavily cratered surface, then we will be it'll be strongly point to Triton requiring tidal heating from Neptune in order to have that kind of exotic surface. So that's really a basic question that we want to answer. We know quite a lot about Pluto in terms of its atmosphere and its moons and its orbit and its surface composition, though there's enormous amounts more to learn from New Horizons. But we know absolutely nothing right now from the geology other than what we are wildly guessing from these still quite low resolution approach images.
And I guess the images are only part of the picture, really, aren't they? Because we've got this lovely picture of New Horizons on the screen at the moment. What other instruments are going to allow you to make those scientific observations and really find out what's going on down there?
Oh, yes, absolutely. We have a high-resolution black and white camera that is what we're mostly using right now. We have a color camera, which also can map the amount of methane on the surface and where the methane is distributed, because it's sensitive to wavelengths of light that are absorbed by methane. But we also have an infrared spectrometer that takes images in 256 different wavelengths of infrared light, which is very diagnostic of what the surface frosts might be. We know there's a lot of absorptions in the spectrum due to methane and nitrogen and carbon monoxide and probably other things as well. And this instrument, the LISA instrument, will allow us to map the distribution of those features across the surface in amazing detail, and will tell us a huge amount about what the surface is made of and the processes that are moving frosts around on the surface. Then we have an ultraviolet instrument that will be probing the atmosphere, particularly as we go behind Pluto and pass through Pluto's shadow. And we will see the sunlight being absorbed by the atmosphere and being received by the spacecraft and picking up the signature of whatever's in the atmosphere. So we will be very interested in the results from that experiment from the ultraviolet instrument. And then we have plasma instruments that are actually going to be tasting directly the molecules that have been escaping from Pluto, and will tell us directly what the atmosphere is made of, maybe how fast that atmosphere is leaking out into space. And that's really unexplored territory, because we've never been to a place like Pluto before, which has an atmosphere that escapes in the way that we think Pluto's atmosphere does. So that's going to be very interesting to get those data back.
We're now just a few days away. What is it that you personally are looking forward to? If we go, say, 2 days past the flyby, what is it, though, at that point that you'd really love to see?
Oh, I am most interested in those high-resolution pictures, because I really want to know whether we do have this active geology or we have a more ancient landscape. And that's the kind of thing that we'll get back pretty quickly. I'm very interested too in the surface composition and how the ices are distributed across the surface. So the surface is incredibly variegated in the images, and so we expect the composition to vary hugely across the surface, and we'll get just wonderful maps of that. And that will take a little bit longer to analyze. So for instant gratification, I think just seeing the kind of landforms we have on the surface and maybe getting some idea of what might be causing those is going to be the thing I think the biggest stuff that we will learn the soonest. And then we'll just have more information trickling in over the next few days and weeks and months after the flyby, and up to a year before we get everything back. And we'll just be learning more and more all the time from all that data.
Well, Dr. Spencer, thank you for speaking to us here on Slooh. We wish you all the best, and no doubt we'll speak again after the flyby and catch up and see what we've actually found out from this flyby. Thanks for speaking to us, Dr. Spencer.
You're very welcome, and talk to you later.
And here we are back with our live imagery. And so here we're seeing a circle around the star, a certain star in the star field, which is not a star. It's a dwarf planet. We're looking at Pluto far, far away as we've been looking at it closer and closer. And so this serves as a great comparison for what travel can do and what more new perspectives we can learn as New Horizons brings back more and more data. And so we can actually do a direct comparison here. So what is we can look at our close image of Pluto versus the live imagery we have. And so there it is. There's a stars field that just has a scattering of light, and then here we have everything, absolutely everything. And so one of the things that John was talking about a bit was how what we might see for a surface, like comparing it with Triton and seeing if we were going to see similarities there and what that could mean in terms of formation scenarios. And what we're seeing actually is some mountains, and you were mentioning earlier, Bob, not a lot of craters, and sort of these mountains of volatiles on top of really this icy sort of surface. And what does that really mean? Like, what context can we put on that?
Well, Dr. Spencer used the words, "I don't know," over and over, and we don't know, and we don't yet know, and we think. And at this point, you have to repeat some of that vagueness. There are things that we do know. I know people are wondering about Pluto in the sky. We just showed our Slooh live view of Pluto. We were actually looking at Pluto. So where is it? How can you find it in the sky? You'd have to say, forget about it. It's in the constellation of Sagittarius, low in the south these nights. So you can point in the right direction. Binoculars? Nope, that's not good enough. Backyard telescope? 14th magnitude, it's just beyond the range of most backyard telescopes. So we'd have to say, forget about that. So look at our close-up view now, the first images that are now coming up. What does this tell us? Well, these are mountains of ice. They're not boulders. They're not made of metals and rocks the way earthly mountains are. You're talking about 11,000 feet tall, like the Rockies, but ice mountains. We knew that Pluto has a skimpy composition, so we didn't expect to see the denser materials there. What's the real surprise is, where are the craters? If this were the moon, we'd be seeing mountains and craters. No craters means, well, on the moon, craters were formed on top of the older terrain. So craters come after the terrain is formed. And once you have lava or liquid melted ice, it erases craters. So then you have to get new impacts in order to see newer craters. But what if there's no craters? Now you're in a situation akin to Venus, which is mysterious, Europa around Jupiter, which is not mysterious. We know that there's no craters because that's floating ice. And the ice gets displaced by water oozing up from below. Seawater, warm ocean, salty water that refreezes. All right, so no mystery why you don't have craters there. Europa around Jupiter, no mystery there. There's volcanism going up. We watched 8 volcanoes erupt at the same time when one of the Voyagers passed by in 1979, and I saw another 7 volcanoes when the other Voyager passed by. So no mystery there. So what we want to do is make this into a no mystery situation. What is producing the youth, the youthful appearance of Pluto, which is what we're seeing? We can eliminate some things. For example, on the Jupiter's moons, tidal heating, because the moons are so close to each other. Plus, they're so close to Jupiter with its huge mass, 318 times more massive than Earth, so that the moons are being stretched out one way and then the other. It heats up the interior. Anytime you have heat, that's going to produce changes in volcanism. But do you have that here? Well, Charon, its moon, is awfully close. It's only 12,000 miles away. In other words, 1.5 Earth diameters could fit between Pluto and its moon. That's awfully close, but no. Charon is only 750 miles across. It's too skimpy to produce the kind of tidal stresses that would create enough heat to change over the surface. The surface is less than 100 million years old. That means it keeps getting changed over. So we have to eliminate active volcanoes. We don't see any. Tidal stresses. It's not that we're looking at a gassy surface. That was one thought, that maybe we're looking at frosts, maybe of solid nitrogen, and maybe that's what's disguising underneath it. But that doesn't appear to be the case either. So what researchers, what theorists are doing right now is they're looking at this and they're scratching their heads. And just as Dr. Spencer told us a few days ago, is it going to look like Triton, Neptune's moon Triton? Well, it doesn't. Actually, nothing does, because Triton is one of the most unique satellites in the solar system. Every part of its surface looks different from every other. It looks like a cantaloupe. Well, we don't see a cantaloupe here. This is not a Triton. But Pluto is more mysterious, I think we could say, than even Charon is, its moon, and they're right next to each other. Imagine only 12,000 miles apart. In other words, 20 times closer to each other than our moon is to us. So we have a different situation, but we have a mystery. So we're replacing one kind of mystery, Eric, that is the mystery of not knowing anything about Pluto, except that it's faint and tiny, only 1,473 miles across, a little more than half the size of our moon. A little tiny object. Pluto would easily fit in half of the United States. You put one edge over Boston, the other half would stretch to about Kansas. So we knew its size, we know its orbit, we know it takes a quarter of a millennium to go around the sun once. We knew about its major moons, but I'm afraid at this point, this is raising as many mysteries as answering them at this stage.
And yeah, I mean, that's really, I mean, hits the heart of it. There's a lot of questions that are being brought up. The more you know a person, the more there is to wonder about them. The same way when you get into detail with a dwarf planet, I suppose. And so we actually do have a question coming up on Twitter from Jessica, who asked, do you think that there is an ocean under the surface of Pluto? Like, is that a possibility considering what we can see here?
Probably not, because this is a lot colder. To have an ocean of liquid water, you'd need a heat source. Now, we've got an ocean under Enceladus, that is one of the moons of Saturn. We have an ocean under the surface of Europa in Jupiter, huge ocean. One apparently recently discovered in Ganymede, another one of Jupiter's giant moons, the largest satellite in the solar system. But here, you don't have the tidal flexing and stretching as a heat source to keep an ocean liquid. So it would have to be some other heat source. What could it be? You're too far from the sun. You're not a large enough object to have still retained heat the way Earth does at its core. And well, if you had a guess, maybe there's radioactivity there. We now think the interior of Earth is hot and molten, mostly because of uranium and other radioactive elements that are providing the heat. So could Pluto have that, even though it's an icy, skimpy body? Could there be enough uranium inside to have heated it up to allow for there to be heat? Doesn't seem plausible, but once you eliminate the impossible, as Sir Arthur Conan Doyle said when he wrote the Sherlock Holmes mysteries, once you've eliminated the impossible, whatever is left has to be the truth, no matter how unlikely. So we're going to be heading towards eliminating the impossible, and then we might be left with some improbable things here with Pluto. Fascinating that this enigmatic body, this object that symbolizes mystery, that people are even bathed in controversy over whether it's a planet or not, that this should, now that we're seeing it for the first time close up, that this should continue to be delivering mysteries to us. I think that's wonderful. It's juicy.
It is, and so this is a time when scientists are just starting to address all these curiosities. So now we have all these questions on the table, and what do we do with them? Well, one important place to start is to be able to figure out what to call all the different features that we see on these objects. And we've actually, the official names aren't quite coming out yet, but we're seeing different leaks of interesting names that the scientific team has been calling different things that have been really significant. Like, of course, one of them had to be Cthulhu. And so if you take a look at the images of Pluto, there's a little bit of a sort of a dark spot or a dark line across the bottom of Pluto that you see sort of part of it there next to the heart, which we will get into some detail about the name for that a little bit later. But so, like the tweet was saying, we got to figure out which dark spot are we pointing to? Oh, we're pointing to Cthulhu. Right. Okay. Everybody knows which spot that is. And so we can figure that out. There's actually also another fun one that came on for Pluto's moon Charon, which, if you remember, there was a bit of a dark place at the poles. And we're colloquially calling that at this point Mordor. And so
Mordor.
the place of darkness. Yeah, and so you're seeing a little bit of a trend coming out of the naming system for these different for the different objects in the Plutonian system that have to do with the underworld. We have Nyx, we have
They
Hydra.
have to, yes, because the International Astronomical Union sets down the rules for naming of features. For example, on Saturn, Titan, all the features discovered there have to be around creation myths. Every object in the solar system has its rules, and they're themes. They have to be characters from Shakespearean plays. They have to be, in the case of Uranus. So here with Pluto, these are all mythologies revolved around the underworld. And but I think there's going to be an exception, isn't there, made for Reggio, revolving around Clyde Tombaugh, the discoverer of Pluto, right?
Yes, the heart. The heart has. Oh, they were just talking about it in the press release that the NASA press conference. Our wonderful NASA partners were talking about how they have renamed the heart to Tombaugh's Reggio, which is a great sentiment.
Tombaugh's Reggio. That means region. It's the region. It's Tombaugh's heart. That's the heart of Clyde Tombaugh, who on March 13th, 1930, announced the discovery of Pluto. He wasn't even a real accredited astronomer. He would say so. So this was his big moment in the sun. We hadn't had anyone discovering a planet. You can't name one person who discovered a planet until since 1781, when William Herschel unexpectedly discovered Uranus. A century later, in 1846, it was a team of people really using mathematics who decided where it must be. And so it's a split and divided accrediting of the discovery of Neptune. But with Pluto, it was Tombaugh all by himself. There he is using a blink comparator. This was an instrument that would look at two photographic plates taken at different times. And if any star or star-like object seemed to move back and forth, change position from one plate to another, you could easily spot it. So this is the way. Look on the bottom of the picture there, and you'll see two plates. You see that? That's even shown in the photographs. You can see the two photographs are of the same star field. Look at those bright stars near the top or the upper left of it, and you can see it's the same star field. And by looking at using this comparator, you can see one little dot changing position. And so to the observer, using this blink microscope, as it was then called, or blink comparator, as it is more usually called, you can instantly detect the orbital motion of Pluto as it chugs along at under 2 miles per second, compared to Earth's almost 19 miles per second orbital speed. So Pluto is moving very slowly. It's very far away, averaging about 40 times the distance that we are from the sun. And so finding this faint, slow-moving object against the stars, in this case, the stars of Gemini, as it was in 1930, was not easy. But Clyde Tombaugh did it, and that leads to what you were just saying. That heart-shaped region. It's been suggested that instead of just mythologies revolving around the underworld and hell and things like that, that one region that looks like a heart will be Tombaugh Regio, if it's accepted, and I'll bet it will be accepted, meaning Tombaugh's region. So it's funny. First, we took away the discovery of a planet from him. Fortunately, after he was dead a few years ago, in 2006, that's when the IAU decided that Pluto planet. And so he never lived to see his planet go from a major planet to a dwarf planet. And then the International Astronomical Union, almost in like, you giveth and you taketh away. Well, they took away the planet, but then now they will probably giveth the most striking feature on Pluto named after him, and a heart-shaped feature at that. So that's kind of that's lovely and appropriate. And I doubt anyone on the naming committee is going to say no to that, even though it's not really a mythology involving the underworld. Although I guess you could argue that since he's passed from the world and he's dead, maybe he's part of the underworld in some sense. There it is. Look at Pluto moving in our Slooh images as Slooh members watch Pluto and have been watching Pluto and taking pictures and comparing them as it's moving against the faint stars of Sagittarius, right toward the direction of the center of our galaxy, though, of course, a lot closer than the center of our galaxy. It looks like it's moving left to right, but Pluto actually moves right to left against the stars. That's because in the images, they can be reversed, they can be flipped. Plus, Pluto recently went through some retrograde motion, a little tiny bit. It doesn't have much retrograde motion because it's so far away, but it moves backward for a brief period of time. And this is the period of time in which it is in retrograde. It was at its closest to Earth of the year just last week. And so centered on its closest time to Earth is when it stops moving right to left and now is flipped over and is going left to right against the stars of Sagittarius. And look at that little Pluto as seen by Slooh members.
Yeah, it's amazing that we can really sort of recreate a sort of a similar sort of scenario as to what little movement that betrays that this pinprick of light is really unique. And we see that pinprick of light here tonight live through the Slooh telescopes, and you see it. We've been putting it up occasionally on the screen with a small little. There it is again, coming into us live from the Canary Islands. And so you see it as something so small, but it means so much, and it opens so many doors in terms of scientific questions that we have been going over, throughout time here. And it's been great to really hear a bit more about sort of the origins of Pluto and where it's come and how far we've been able to come with it. And could you speak maybe a little bit, Bob, about what we knew about the dwarf planet in the beginning? That what sort of knowledge could we have about this when we were so distant from it and it was so insignificant looking in the background of stars?
Sure. Well, just as Uranus did not move in an orbit that was predicted, it looked like some other planet was tugging at it, and that's why it led a Frenchman, Leverrier, and an Englishman, John Adams and Leverrier. I forgot Leverrier's first name, to both correctly predict where Neptune would be, and finally it was discovered and announced on September 23rd, 1846. And so after that, of course, people wondered, well, are there other planets out there? And both Neptune and to a lesser degree Uranus seemed to not be quite moving the way it was expected they should move. And so Planet X was thought to exist. It was a particular obsession with Percival Lowell, and at the Lowell Observatory, still a wonderful observatory out in Arizona. This is where the search was concentrated, and at this observatory, Clyde Tombaugh discovered it in 1930. Well, it turned out, unfortunately, that as more information came in, the planet was obviously too low mass, lightweight, to really be tugging at Uranus and Neptune. And now we find that Uranus and Neptune don't have any odd motions after all. And Pluto, it's just by chance that it was found there in the constellation of Gemini that year. So as time went on, we saw it was much smaller than we thought. And then we found that it was a double object. If we're going to call it a planet, it's a double planet because Pluto and Charon only have a 2-to-1 mass ratio. As I say, Charon is 750 miles in diameter. Pluto is just under 1,500. So that's weird. There's no other planet that has that kind of ratio. Earth is next, but the Earth moon size ratio is 4-to-1. We are 4 times the diameter of the moon, and we're 81 times the mass of the moon. So we're almost a twin planet ourselves, we and our moon. But Pluto and Charon have that beat because they're so similar that they don't even go around. One does not go around the other. Charon does not orbit Pluto at all. The two of them orbit the common center of gravity in between them. They both go around an empty spot of space every 6.4 days, and they both keep one side, one hemisphere facing the other. So although our moon, in fact, all the other satellites in the solar system as well, has only one face facing their parent planet, just like the moon does to us, in Pluto's case alone, Pluto itself also has only one side facing Charon. So if you lived on Pluto, I think your real estate values, your taxes and everything else would depend on where you lived. On one side of Pluto, you'd have this beautiful view of the moon, this big looking moon because it's so close, only 12,000 miles away. Big looking moon, Charon, always in the sky, always in the same spot in the sky, by the way. And on the other side of Pluto, no trace of it. It would be moonless, Charonless, no trace of any moon forever. So weird situation. As time went on, we found that Pluto not only orbits in a very highly inclined plane, 17 degrees, more than any other planet. Previously, the most tilted orbit was Mercury's at only 7 degrees. So this is very highly inclined plane, tiny object, elliptical stretched out orbit with a 3-to-5 ratio, much more elliptical or oval than any other planet. And we could have lived with all of that. Pluto would have stayed a planet if those were the only eccentricities. The problem was finding more Plutos out there. It became obvious that Pluto is merely the nearest member of a innumerable icy bodies that we now call the Kuiper Belt. And because of that, finding Quarwar, Sedna, Makemake, and Eris. Eris was really tough because Eris is heavier, more massive than Pluto is. And we thought it was even a little larger. Now it turns out it's just a tad, a few miles smaller than Pluto. But the point is, there's more of them. So if Pluto is a planet, some of these guys have to be planets. Certainly Eris does. And some of these have to be too. So you had two choices. Either you're going to make all of these Kuiper Belt objects, or a lot of them, into planets, and you're going to have a lot more planets than you did before, or you divide it up into two categories. You have the 8 giant planets from Mercury on out to Neptune, and then you have a separate BIM, separate category for these very small planets in strange orbits, highly elliptical, highly inclined, tiny icy bodies that are very different from the first 8, and you call them something else. So we're calling them Kuiper Belt objects. Pluto probably should have just been a Kuiper Belt object, but instead we're calling it a dwarf planet, a different category, and that's how it stands. That's how it's probably going to continue to stand. And so that's Pluto's history. But now we have a new chapter starting today as the first images come in, and actually starting in the last week while we saw more and more and more, because Pluto's gone from a little dot, or even in the Hubble Space Telescope, a few smudges on it, to details, some of which are explainable. For example, icy mountains, that's not too surprising, mountains of ice on this object, to a lack of craters, which is surprising. And what about the volatiles on the surface? We know that Pluto has a very, very thin atmosphere. And because of that orbit that takes it from 30 Earth-Sun distances out to 50, it was at its closest in 1989. when it was closer to Neptune. When it's that close to the sun, some of the nitrogen on the surface, that's solid nitrogen, turns into a gas, and it's got a nitrogen atmosphere, much thinner than ours, and much thinner than the one that surrounds Saturn on its moon Titan. But still, gaseous nitrogen, some gas outgases, and sometimes it's in the form of solid thin layers of nitrogen on the surface. So weird stuff going on, and we're only beginning to understand Pluto. This opens up today opens up a new chapter in our exploration of this tiny planet.
It really, really does. I mean, I just think back to yesterday during our second of our three New Horizons broadcasts, where together we said hello Pluto as it came and officially New Horizons approached the dwarf planet, and we have so much more to come. The scientists on the team were talking about how they're just throughout even the year they're going to go through this data with a fine fine comb and figure out exactly sort of what's going on when it comes to a lot of different things that are happening there. And of course, I'm really glad that you brought up sort of Kuiper Belt objects, because that's going to be very important to a continuing path of this whole mission. But before we get to the future of New Horizons, I wanted to tell you a little bit about also some interesting objects that are sort of similar in a way to what Slooh members have been looking at. If you remember, 67P had a similar, really absolutely incredible hullabaloo going on about it, being the first Philae lander and landing on the comet and all of that drama. It was pretty incredible to watch, and I hope that some of you Slooh members were watching that live with us as well, because that was gosh, a story in the making. But we also Slooh members are looking at 67P now, and they're part of a special program, actually, that's a professional amateur collaboration, where there can't be enough data about 67P, and Slooh members are actually accumulating the largest and most consistent set of image data for this project. And so if 67P is something you're interested in, Slooh members, you might as well check that out, because we have a lot of that data coming through all the time. And of course, we will have a special show in August where we'll be using one of ESA's largest telescopes to image a 67P. And so, yeah, again, if you're a 67P fan, there's a lot of things coming up on the horizon for you. And of course, you can't forget our shows that are coming up in just a few days' time this month. We have a really special show on Sunday that's going to be covering the $5 trillion asteroid. What does it mean for an asteroid to be $5 trillion? We'll find out, and maybe talk a little bit about what the future of looking at these close asteroids can be in terms of landing on them, mining them. What's going to go on there? That's going to be Sunday, July 19th. And of course, you can wish upon a star with Slooh on Tuesday, July 28th, when the Delta Aquarids come by. And so we're sort of beckoning in the meteor showers of today. They're coming into season now. And so look forward to much more meteor showers coming up over the horizon with Slooh. But of course, do excuse my pun. But speaking of New Horizons, we are going to be looking forward now that we have passed by Pluto. What is the future for this spacecraft? What is it going to do? Is it just going to fly off into oblivion, or is there more coming for this spacecraft? Is there more it can do? What do you think about that, Bob? Are there new horizons for New Horizons?
Well, yes, because there are Kuiper Belt objects beyond it, more to be discovered, some that can be accessed. If we get lucky and the spacecraft continues to survive, its energy source should. It's 24, creating a reliable 200 watt. So as long as for propulsion, because the thing is moving at 8 miles per second and is heading out, where you just need little changes or more Kuiper Belt objects and get to see those close up. We probably won't get to another perfectly round one. Maybe 50 miles across is round. Perhaps there were more spherical objects as well. Hopefully they'll all get cool names like Pluto did. Incidentally, Pluto was named by a schoolgirl. It got named by the cartoon dog. But no. Disney's only cartoon. And the Disney company decided that with all the publicity over the newly found planet Pluto in 1930, by the next year, 1931, they had changed the dog's name to Pluto, just to take it, because the first two letters, PL, are the initials of Percival Lowell, at whose observatory Pluto was found, and who was the most tireless hunter for Pluto before Clyde Tombaugh finally found it. So it's really an appropriate name. Everybody loves it. It's one of the appeals of Pluto. So hopefully when we get to further Kuiper Belt objects, right now they have kind of almost humorous or hard to pronounce names: Maki, Quarwa, Sedna, Eris. There's a few others that are odd as well. We'll see what happens. So it's not over. Just as and with that plutonium, it's really not going to be over. The Voyagers that were launched at the edges of the solar system, where the heliopause exists, that is where the solar wind by the incoming gentle pressure of starlight from the rest of the galaxy. That's where the Voyager signals and information and measure the subatomic particles that are hitting them. So hopefully the New Horizons spacecraft will have a long life for decades to come, and who knows what it's going to find. So in a way, this is the most important stop, but perhaps its discoveries are just beginning.
Absolutely, yeah. And as it's going further and further out into the depths of space, expanding our own knowledge of our own solar system, our stellar home, we'll be there. We'll be there to cover it. So if whatever Kuiper Belt object it goes past, look for Slooh to see what's going on. And as we're sort of heading to the end of the broadcast here, we still actually have a couple questions, and we're so glad that you guys are curious and asking us some things about Pluto and the whole mission here. And so again, if you have questions, use the hashtag #SloohNewHorizons. We have a couple more that we can cover. One that we can speak to here that's coming from Josh is asking us, when will we see the dark side of Pluto? And there's actually a unique sort of strategy that's going to be applied to try and see that, isn't there, Bob?
Yes, that is so cool. That is, the dark side of Pluto will still be lit up by the almost full light of Charon. So in other words, even though Charon is a kind of darkish object, it's going to reflect sunlight. And the sunlight back at Pluto's distance is about 1,500 times fainter than the sunlight we get, just because the sun is so far away. But don't think of the sun as just a star from there. It is still too bright to look at. If you were to stare at the sun from Pluto's distance, it would still hurt your eyes. So it's going to hit its moon, bounce off its moon to the dark side, and so in Charon light, Charon shine. Some people are familiar with the term earthshine. That's when you look at a crescent moon and you can see the dark side of the moon. The part of the moon that's not a crescent is being lit up by the light from Earth. It's called earthshine. So they're going to try to image the dark side of Pluto by Charon shine. What a term, right? We've never heard that expression before, but now it's introduced into the English language, at least briefly. Charon shine. Well, let's see if they're successful.
And yeah, they were mentioning during the NASA press conference that might be a bit of a tough one. So we'll see whether it happens, but that would be really great if they were able to pull that off. And so, as we're looking back on Pluto now, as the imagery is coming through, can we say at this point, there's actually a question coming in from Jesus, who's asking, would there be any reason to send any more space probes or flyby missions to Pluto, or do we have pictures that give enough detail? Something I'll add to that: is there any reason to land on Pluto? And why didn't we land on it this time? Was there any reason for that?
Well, the amount of energy you would need, the amount of fuel, and therefore a heavier spacecraft to be able to slow down from the 8 miles per second, go into orbit even, would have required a much more expensive mission. And unfortunately, expense is the bottom line. When you ask yourself, what do you want to do and what do you want to do next? There's a whole list for planetary researchers who would love to go to Europa. We all want to go to Europa because that's the most likely place for life. For goodness sake, there's warm saltwater oceans. Life started in Earth's oceans. So, wow, do we want to go to Europa and burn our way or drill our way through what's perhaps a mile thick of ice and see what, if anything, is swimming or floating in those oceans there? So that's a priority. There's a lot of closer places. Remember, Pluto is still very, very tiny, and we've got our images. There's no talk about going to the very strange cantaloupe-shaped moon of Neptune, Triton, one of the most intriguing and weird objects in the known universe, and nobody's suggesting going back there. So there's lots of competing missions. Remember, it took 9 years, the fastest ever spacecraft to blast off from Earth on an Atlas V rocket. Still took almost a decade to get there, and would that be funded again? I doubt it, because money is always tight, and you have to decide what you want to do and what you can't do.
And so the scientists on this mission were under the pressure of economy and getting as much as they could from what they could from this one opportunity. And so we'll see all that comes through with that. And if there's anything really crazy, hey, maybe we'll have a reason to go back. But yes, this being very much a one-time thing, I think, in a lot of our minds. But we've been looking over this past week at an incredible journey, a really, really beautiful journey in terms of science, in terms of our relation to our solar system. We've seen the images leading up to this incredible flyby. We've witnessed the flyby ourselves on here on Slooh, and now we're talking about the ramifications of that. What is coming out of it, and what does it mean? And there's going to be so much that continues to be released about Pluto in the days coming, in the months coming. And so, yes, if you're a crazy Pluto fan and you didn't catch our last two broadcasts, check back in the clubhouse. We have the first and second part of our New Horizons special just waiting for you there. But yeah, we're coming to an end of our special 3-part series, which it's a little bittersweet, because it's always lovely to have just image after image and sort of eureka after eureka coming through, and this has been quite a week of excitement. And I was just wondering, Bob, did you have any sort of last thoughts about really this amazing mission that still isn't quite done yet?
Well, yes. Well, what I'm looking here, just through the eyes of science and through the eyes of sheer impact, beauty, is at what scale, Eric, do we see the most fascinating details? For example, as you approach Jupiter, when you're too far away from it, you just see stripes. When you get closer, you see things like the Great Red Spot. But if you look too close, you're left with a single cloud, and you lose interest. Similarly, on the moon, anybody with a backyard telescope can zoom in and see some fascinating details, like the crater Copernicus with its terraced walls leading down to its twin-peaked mountains, and that's gorgeous. But when you get too close to the moon, as the Apollo astronauts did, well, the science is certainly there, but when you zoom in on the surface, what have you got? You got a rock. You could shrug your shoulders. It's not intrinsically beautiful. It's a rock. You want to analyze it, you'll find some interesting things there, but it's not beautiful. So as we look at this, Eric, and as we have now for the last few days, at what scale, as we approach Pluto, did we get our greatest drama? Is it this first close-up where we're seeing mountains? Well, honestly speaking, we see mountains on other celestial bodies, on asteroids, on the moon, mountains that look like this. Will anybody looking at that say, that's the most amazing thing, those mountains? I doubt it. Now look at this image taken on July 9th. Now here we've got Pluto and its dark moon Charon compared. Now this is pretty dramatic, the color contrast. And as we got closer, we got to a scale. Here we go on July 6th, which we even saw in more detail a few days later, where we've got a heart, a white heart, and there it is in more detail. So you're asking me for an impression. My first impression is that at this scale, for now, we saw the most dramatic and bewildering things on Pluto. Of course, this is only the first of a treasure trove of images. Probably as we get more close-up images, we're going to have plenty of fascinating details to look at. But for the moment, I think the most visually stunning were the images when we could see the whole planet and the planetary geography as one. Close enough to see detail, instead of it just being the blurry dot that it has been for all these decades. And so we'll see as more and more images come in, and they're not all going to come in until next year because New Horizons took so many pictures, and it's a long way and a slow process of sending all these pixels. So as they come in, it may even be too early to make a final assessment of it. But we got lots of different scales, lots of different details. And how often in our lives, Eric, can we say that here is a final visit to one type of celestial object, in this case to a planet. We visited Ceres already, that's the other dwarf planet, and here is Pluto. This almost like closes it up for now. And so it's a memorable time. I think we'll always remember this week in astronomical history, especially here at Slooh, where we've been watching this live.
Yeah, we've been here through the whole journey, and yeah, thank you so much to Slooh members for coming along with us for the ride. And we see here in the top left of the screen, there's the star field. This is what the person who we named Tom Bowes Reggio after what they were looking at. This star field with pinpricks of light and just moving subtly across the screen. And now here we are looking at something where we don't even see the whole dwarf planet in the frame. We see detail of that was, I'm sure, unimaginable at that time. And so we've gone from very far to very close up, and it's quite an accomplishment in science just to see that right in front of your very own eyes. And yes, thank you again for coming along with us for this journey. And yeah, don't forget to tune into our next shows just coming up right around the corner. We have the $5 trillion asteroid that's coming up this Sunday. And of course, we have a meteor shower coming up just a little later than that. But yeah, there's a lot more coming around. But for now, this has been quite a fantastic week in terms of science, beauty, and our perspective on our own solar system. So thank you, Bob, for joining me today. Thank you, Slooh members, and all of our audience for watching. But for now, this has been Bob and Eric for Slooh. We'll see you again.